Hi guys, Dr. B here. This is topic 2.4 for AP Chemistry, Structure of Metals and Alloys. The objective is to be able to represent a metallic solid and or alloy using a model to show essential characteristics of the structure and interactions present in the substance. A couple of essential knowledges that we need to always be mindful of. Metallic bonding can be represented as an array of positive metal ions surrounded by delocalized valence electrons. Interstitial alloys form between two atoms of different radii where the smaller atoms fill the interstitial. Well, we're going to talk about that in a little bit. So two types of alloys we're going to talk about: interstitial and substitutional. Metals are composed of cations that are embedded in delocalized C of valence electrons. This means that electrons do not stay with one atom, rather they're able to move through the entire substance. The cations and the electrons are attracted to one another through a Coulombic attraction, which holds the metal atoms together. In this image, you can't tell which electron comes from which cation. This is the idea of delocalization. The number of valence electrons determines the amount of electrons in the delocalized sea of electrons. When the charge on the cations and the number of electrons increases, the attractions are greater. Additionally, when the ionic radius decreases, the attraction increases. So a lot of topics we're covering early on from Unit 1 and now here, even in here, we're still talking about Coulombic attraction. So you're going to hear this a lot. So you should know it and pray and hope that you get this type of question on your AP exam. I don't think it was on the 2024 one or like the previous one, but if that's the case, it may show up in the 2025 one, so maybe a good idea. So you'll notice here the group 1 metal, for each ion, there is one electron. For each 2 plus ion, it looks like there are 2 electrons associated with it. Mixtures of metals are called alloys. They can be examples of a solution. Two types of alloys we're going to talk about are interstitial and substitutional. The difference between them is the size of the atoms that are being added to the metal. Interstitial. The atoms added to the metal are small and fit in between the metal atoms in the existing holes, or interstices. Common elements that are added: hydrogen, boron, carbon, nitrogen. You can see we have carbon and iron. This is an interstitial solid solution. You can tell that it's interstitial, so like the idea that it's inter/between, so they are all in between each of the metal ions. A substitutional alloy, the atoms are added to the metal and have similar radii, so they substitute the substitute atoms that are found in the lattice. Okay. Just for your own edification, carbon and iron is steel, that type of alloy, and copper and nickel, this alloy, copper nickel or copper nickel. Very, very original. Carbon steel is an alloy composed of a small amount of carbon atoms found within iron. Consider the atomic radii of both and draw a model that describes the alloy that forms. So we just kind of saw it, but assuming we didn't see it, what you have to do is recognize the comparison of the atomic radii between each of the elements that are there. Now, carbon is way smaller than iron, so that means that most likely this will be an interstitial alloy, which we did see. So remember that when you are doing a diagram, you have to include a key. So let's say this is our iron, and this is going to be our carbon. So we're going to have a bunch of iron. Try to be as consistent as possible. It doesn't give us the amount that we need of each atom, but be mindful if it does. So we're going to see some examples later on. So something like this. It's a horrible drawing, but gets the point across. Examine the diagrams below, then label each with the type of substance shown. So the red circles represent the metal, and the blue and the green circles represent whatever extra elements. So the first one on the left, we didn't really talk about this, but it's kind of simple once you hear it. So if it's all just the same element, same metal, this is called a pure metal. Original, I know. Looking at the other two, you can probably guess. So you see the blue takes the place of a red. So this is a substitutional alloy. And the last one's going to be interstitial alloy. All right, gentlemen, that's it for now. Let me know if you have any questions. Thanks.